you're going to be going, oh man, but then this is kind of hard. But as you start doing it, I think you'll be okay. Laugh out loud. What does that mean, Carlos? Are you throwing me? Wait, are you saying I'm wrong? You throwing me? Hey man, I have control of your grade, man. Don't talk back at me. I see what you're trying to do there. All right. Anyway, laugh out loud. Oh, Carlos is telling me to laugh out loud. Okay. Oh my. Oh geez. Oh my gosh. Stop. Stop. Okay. I'm looking at all of you. I'm sorry. You all seem angry. I'm sorry. I'll move on. Okay, I'll move on. I'm not distracted. Don't be angry. You guys, 7 days left of this. I know some of you saying 7 days left of this crap, and then we're done. No more. Don't have to worry about it. Okay. Where are we? So let's talk about polar form and graphing form for the equations by looking at our delta math. Now remember delta math. Did anyone have any trouble with the delta math? Speak up if you did. Otherwise, because I'm not looking at you right now, because I'm looking into my delta math log, as you can see. I can't see you guys. I can only see my delta math. Does anyone have trouble with it? If you did, let me know, because this is due on Friday. This is due on Friday. So let's look at what I had you guys do. Remember, there's one page for everything, right? We did plotting complex numbers and plotting polar points. So remember, polar form is this right here, 4, 7 pi over 6. So what that means is we go over the angle, we go over, right, we go here, and we go, I'm going to do it this way. I'm going to go over 4. 4 is the radius, 1, 2, 3, 4 is the radius, and then I open my angle, see if I can stay on that circle, all the way to 7 pi over 6, right? And that's polar form. Now remember, it's very important. This is the radius. The 4 is the radius, okay? You got to know that. So put R on your notes or whatever. And 7 pi over 6, that is the angle, or theta, okay? Theta. So 4, 7 pi over 6. So we're going to have to change this into rectangular form. Now, another thing you guys are going to need is your unit circle in order for this to work out, right? If you look in your canvas, I put up a unit circle for you guys. Okay, so let's go on the canvas. Okay, I'm going in student mode, and let's go to, so okay, here's your canvas page, right? This is my canvas page. This is your canvas page. Okay, and go in the modules all the way to polar coordinates. Here I put in the unit circle. Okay, am I going too fast? I feel like I just did that too fast. I went very fast here. Let me go back. Okay, so I'm in the modules. Okay, and in their polar coordinates, at the very bottom, there's the unit circle. Okay, that little module. Click on the unit circle. And I have the whole unit circle all filled out and everything. Even though you guys have your own unit circle with your notes, here's the unit circle all filled out. This is going to help us to solve going from polar coordinates to rectangular coordinates. Okay, so everybody make sure you have that a unit circle out. Make sure you have the unit circle out, either on the computer or on a piece of paper. Okay, have this unit circle ready. I'm telling you, you're going to need this today. I'm going to be calling on you, and if you don't have your unit circle, you're going to be super confused. Okay, so make sure you have your unit circle. Do you need time to get your unit circles out? Let's see. Let's check. Madison, do you have your unit circle, or do you need time to get it?
I have it.
All right, cool. Very good. Roberto, do you have your unit circle? Do you need time to get it?
No, I have it right now.
All right, awesome. Taylor, how about you?
I have it.
Nice. Marilla, do you have your unit circle? Do you need time to get it?
I have it.
How about Joshua?
I got it.
How was your birthday yesterday?
Oh, it was good.
Yeah, how's the habit? What'd you order?
The Santa Barbara char with fries.
Oh my gosh, that sounds so good right now. Okay, well, happy birthday. Hope it was good. You said it was good, so I'm glad it was good. I hope it was everything you hoped for. All right. Okay, so let's see if I can find a good one here. Let's see. Oh, submit answer. Oh, my answer is incorrect. What did I do wrong? 1, 2, 5. Oh, I gotta go up one. Okay, so this I'm trying to find one that I can do a good. Okay, well let's do one of the homework problems. Okay. I'm going to explain it through the homework problem. Now remember, yesterday you did all the plotting polar or plotting rectangular coordinates. Today, you're just doing polar coordinates to rectangular form. Anything that goes polar coordinates to rectangular form, you're going to do. There's 10 of them. The next section, I'm going rectangular coordinate to polar form, okay? I have not taught you how to do that, so you do not know how to do it. You might be able to figure it out. If you figure it out, hey, knock yourself out. Go for it. But we're going only polar coordinate to rectangular form. So here you go. Okay. So what we're going to do is, this is polar form, 4√3, comma, pi over 3. Okay. So wait, am I even showing? I'm probably not even showing. I'm not presenting. You guys got to say something. Or maybe you guys don't even know. I'm being, if you know, if it looks like I think I'm presenting, let me know. That way it saves time. You guys probably even know what I was doing here. But anyway, let me go back. Remember here, we did the plotting. Oh dear, what just happened? Okay. Turn to teacher account. Tools. Okay, let's go back. Okay, so we guys did all the plotting yesterday. Today we're doing polar coordinates to rectangular form, right? All those polar coordinates to rectangular. There's 10 of these. And then tomorrow we're going to go from rectangular to polar. Okay, I'm going to show you how to do that. Now, you might be able to figure out by doing this backwards, you might be able to figure out how to get this. So I guess knock yourself out if you want to do it. I know some of you are, have super smart brains and can figure that out for yourself. Go for it. But I'm going to show you that tomorrow. So don't expect, if you're like, how do you do that? I don't know. Since I didn't show me. Well, I haven't shown you yet. But here's the first problem. Going from polar coordinates to rectangular form. Okay. So convert the polar coordinates 4√3, comma, pi over 3. Okay. So that's what we're going to do. So we're going to make that's polar form. And we're going to change it to rectangular form. So let's do a picture and see what this looks like. Oh, my visualizer is not connected. Visualizer. Oh, I gotta plug it in. Plug it in. There it goes. This should work now. Okay, here we go. Okay, so, okay. Let's try this again. There we go. Okay, so we want to convert this into rectangular form. Now, this is the radius for root 3, and this is theta, pi over 3. Okay, so the form is radius comma theta, right? Instead of x and y, we have the radius comma theta. Now I'm doing my best to draw this picture. Okay, so just so you can see, you don't need to draw it, but just so you guys get an idea of what's going on here. So somewhere 4 root 3 will be like 1, 2, 3, 4 root 3, somewhere out here. And then pi over 3 is here. So best as I can, the coordinate will be like right about there. You guys see this? So my angle is pi over 3, and my radius is 4 root 3, right? If this was a circle, that's what it's going to look like. That's the coordinate. Now, rectangular form, so the coordinate polar form tells me how far to go the radius and how big to open the angle. We want to convert that to rectangular form where there's like an x coordinate and a y coordinate, or a real number coordinate and an imaginary number coordinate, right? Rectangular makes a rectangle. How far right, how far up, or how far left and right, how far up and down. Okay, so this is polar form. I want to change it to rectangular form. Okay, so now let's draw another picture. Okay, actually, you guys draw this. I want you to draw this. So here we go. I'll give you a second to see what I'm going to draw. I'm going to draw this little section out here. What do you mean by that, Sensei? Well, I'm going to make it bigger. I'm going to magnify it. And there you go. Okay, so what I did is I made a triangle here. I took this and I made a triangle. In fact, let me go like this. Let's call this, this will be my, we'll call it Y for now. And then this, for now, we'll call this, you see that's green. This will be my X. So here is my X, here is my Y for my rectangular form. How far do I go this way? How far up do I go? A lot of times, like we talk about that this is the real number and this is the imaginary number, right? Either way. But right now, I think it'll be easier for us to call it X and Y for now because I think that's easier for us to understand. Now, again, this is over here. This is pi over 3, and this is 4 root 3. Okay, are you drawing that picture? I demand that you draw that picture out. That picture needs to be drawn out. So you need this drawn here. It's very important you have it so that you understand what the heck is going on. I'm giving you a second to draw it out. Okay, I'm gonna remove this in 10 seconds. Let me know if you need it. 5, 4, 3, 2, 1. Okay. Okay, so we should have all had that drawn out, right? Okay. Jacob, did you draw it?
I'm trying to figure out how to get to that. Like my thing is my Delta Math. I'm still doing the plotting from yesterday, and I'm trying to figure out how to get back and go to where the assignment is.
What? Wait, I just want you to draw the picture, man. Did you? This talk to me after class about the Delta Math.
All right.
But draw the picture. Stay with me on the. Stay with me on this because you're going to be totally lost, and then you're going to be super lost. Okay. So
All right.
stay with me on this. Jose, did you draw it?
Yeah.
Okay, good. Jaylene, did you draw it?
Yeah.
Okay. All right, Jasmine. BRB means bread run back or something. You're gonna get bread. I don't know. Natalia, did you draw it?
Yes.
Okay, very good. So I'm going back now. Jacob, catch up with us, okay? Let me know if I need to slow up. Okay. Here we go. So now that we all have this drawn out, okay? let's figure out how far across that we go, which we'll call the x, okay? Now, do we know how to solve for x? Do we know how to solve for x there? Do we know? I'm asking you. Taylor, do we know how to solve for x now? At this point, do we know how to solve for x, given the information that we have?
No.
Wrong. Try again.
Do you use trig?
Well, do we know how? Just say yes or no.
Yes.
And yes, we do. And you're right, we do use trig. Right? Taylor's 100% correct. We know how to do this. And trig is Sohcahtoa. It's going to help us out. This side, right? Hypotenuse, opposite, adjacent. If I want to solve for x, do I use sine, cosine, or tangent? Now that you guys know that, now that Taylor said, hey, we use trig. Matthew, what do I use to solve for x here? Sine, cosine, or tangent? Solve for this x.
Tangent?
Why do you say that?
Wait. I'm not sure.
Well, why'd you say tangent?
I don't know, I guess.
Matthew,
Yeah.
do you know what Sohcahtoa means? What it stands for?
Oh, opposite, hypothesis, or hypotenuse.
Hypotenuse. No, it's going good. Keep going. Sine is opposite over hypotenuse. What does it see?
Adjacent.
Cosine is adjacent over hypotenuse. What's T?
Opposite and adjacent.
Tangent, opposite over adjacent. Okay, so I'm solving for x. Matthew, you with me?
Yeah.
What side is this? Opposite, adjacent, or hypotenuse? This x compared to this angle right here.
Adjacent.
Adjacent? Now, this is the one I'm given. What side is this?
Hypotenuse.
So what I'm going to use, adjacent, hypotenuse, sine, cosine, or tangent?
Oh, cosine.
Very good. Okay, so let's solve for this. So we're going to say cosine of pi over 3. Remember, we put the angle there. It's in radians now. We know what radians are. Instead of degrees, we do radians. Cosine pi over 3 equals adjacent x over hypotenuse 4 root 3. Now I need to solve for x. So what do I need to do to solve for x? Just tell me what I multiply, divide, add, or subtract by. Morella, how do I solve for x?
You're going to multiply both sides by 4 root 3.
Very good. So let's say 4 root 3 times 4 root 3. So this goes away. X equals cosine pi over 3 times 4 root 3. So I'm going to write it like this. Watch carefully. X equals 4 root 3 times cosine pi over 3. Now I'm going to stop there for just a second and pause. Let's make sure we understand how we got that. So we said cosine is pi over 3 equals to x over 4 root 3. So I solve for x, and now it's x equals 4 root 3 times cosine pi over 3. Okay, now, here's what I want you to do. This is the most important thing of this whole lesson here. Let's write this in a way that we can use it all the time. Let's make a formula. 4 root 3. What is that in our two numbers here? What is 4 root 3? What is my 4 root 3? What is my 4 root 3? What is that? Let's go with Madison. No, not Madison. I think I called you. Let's go with Kayla. What is 4 root 3?
It's your radius.
It's your radius. Very good. So instead of 4 root 3, let's put radius times cosine. Whoops, here we go. Sorry. So instead of 4 root 3, we're going to put x equals the radius times the cosine pi over 3. Okay, what is that as far as our equation goes? Pi over 3. What's our pi over 3? Giovanna, what's my pi over 3?
I don't. Oh, wait. I don't remember. Sorry.
Is this?
Yeah,
You
that.
don't
I don't
remember?
remember the name of it. I don't remember the name of it.
Okay, this is called theta. Or you
Okay.
can just say it's the angle.
Okay.
All right. So anyway, so x is equal to r times cosine theta. I want you to take this equation, this formula, star it, highlight it. If you did not learn anything, this is the most important thing that you got to know for this lesson right here. X equals r times cosine theta. Write that down. X equals r times cosine theta. Okay, make sure you have that down, or else someone in my second period class didn't write it down. I could tell they weren't paying attention to class. So if you don't have this down, it means you're not paying attention. Write this down. X equals r times cosine theta. Okay, let's continue. Let's solve this now, okay? So to find the x, remember this is the x coordinate. To find the x coordinate, 4 root 3 times cosine theta. This is where we're going to take our unit circle, and we're going to find the cosine of pi over 3. Let's do that first. What is the cosine of pi over 3? Well, what I'm going to do is I'm going to look at my unit circle. Remember, cosine is x, sine is y. What are you talking about, Sensei? Okay, here we have pi over 3. You guys see this? We want the cosine of pi over 3. Remember, the cosine is x right here, and the sine is y. So cosine of pi over 3 is 1/2. Cosine of pi over 3 is 1/2. Okay, you guys see that? You understand the cosine? We use the unit circle to find the cosine of pi over 3. You cannot do that with the calculator. You need a unit circle. Again, the cosine of pi over 3 is equal to, this is x is cosine, y is sine, 1/2. Okay, I'm going to go over here. Okay, here's my live version, right? Cosine pi over 3 is 1/2. So now I can rewrite this as x equals 4 root 3 times pi over 3. Cosine pi over 3 is 1/2. And now we can solve it. My x coordinate is 4 root 3 divided by 2, which equals to 2 root 3. That is my x coordinate. Okay, so how do you solve for the x coordinate? You don't need to draw all this out. All you need to do is just say x equals the radius times cosine theta. Plug in your radius, figure out what cosine theta is, multiply them, and you get 2 root 3. Let's solve for y. I'm going to pause here for a second if there's any questions. Okay, let's solve for the y coordinate. Okay, going back. This is my y coordinate, or the I, but we'll call it y for now, solving up and down. I have this angle, this side, this side. Okay, what do I use? Sine, cosine, or tangent to solve for y. Here we go. I'm going to call on someone. Sine, cosine, or tangent. Do I use sine, cosine, or tangent? Let's see. Jasmine, what do I use? Sine, cosine, or tangent? Solve for y.
Tangent, I think.
How'd you get that?
I just guessed. I don't know.
Okay, well, let's see. What side is we're going to solve for y, right?
Yeah.
Jasmine, you there?
Yeah.
Okay, we want to solve for y. What side is this compared to this angle? Opposite, adjacent, or hypotenuse?
It says that it's reconnecting. I don't know.
No, that's not the right answer. Is it opposite, adjacent, or hypotenuse?
I can't see the screen anymore. Hold on.
Oh, you can't see it? Okay. Stay with me, Jasmine. I'm going to call on you just a second again, okay? Gracie, what do I use, sine, cosine, or tangent here?
Sine,
Sine, very good. Why?
because it's the opposite and the hypotenuse.
Very good, right? We're solving for the opposite side. We're given the hypotenuse. So let's go ahead and set up our equation. So the y is going to be sine pi over 3 equals opposite y over hypotenuse 4 root 3. To solve for y, I multiply both sides by 4 root 3. I know I'm going fast. There's a reason. So y is equal to 4 root 3 sine pi over 3. Y is equal to 4 root 3, which is the radius, times sine pi over 3, which is theta. So guess what? Y is, I know I'm going fast. Am I going too fast? Stop me if I'm going too fast.
Very fast.
Yeah, you're going fast.
Okay, I'll stop. Are there questions? Okay. Assuming there's no questions, I'll just pause till everyone's caught up. Let me know if you have questions while I'm pausing. Okay. I'm assuming I can go now. Stop me if I'm going too fast. Okay, y is equal to, remember, this is the radius times sine theta. Again, just like the x, this is the most important thing that you need to know is this thing that I'm putting in green right there. Y is equal to r times sine theta. X is equal to r times cosine theta. Y is equal to r times sine theta. X is equal to r times cosine theta. If you haven't learned anything, those are the two things that you must know from this lesson. Those are the most important things. I'm showing you how to get it. If you don't get that, all you need to know is y equals r times sine theta, x equals r times cosine theta. So go in here. Y equals 4 root 3 times sine theta. Okay. Sine pi over 3. Take your unit circle. Find pi over 3. X is cosine, y is sine. So sine pi over 3 is equal to root 3 over 2. Sine of pi over 3 is equal to root 3 over 2. So this is equal to y equals 4 root 3 times root 3 over 2. Sine pi over 3 is equal to root 3 over 2. So you guys try to solve that. 4 root 3 times root 3 over 2. See what you get. 4 root 3 times root 3 over 2. I'm going to call on one of you. See what you get. 4 root 3 times root 3 over 2. What is that? What is y equal to? Give you about 40 seconds to solve that. 4 root 3 times root 3 over 2. 4 root 3 times root 3 over 2. Alex Garcia, do you need more time?
Mr. Sanchez,
Yeah.
I just dropped all my food on the floor. Give me a second.
What? Okay, I'm sorry. That's terrible. That's the worst. I'm sorry to hear that. Hope things goes okay. Ariana, do you need more time?
No.
All right, cool. Brandon, do you need more time or are you done?
I think I'm done.
All right. I'm curious as to what you got. What'd you get, Brandon?
I got 6.
What? That's what I'm talking about. That is the correct answer. Never, ever, ever let that down, Brandon. You got it. You're the man. Yes, it's 6. Raise your hand if you got 6. All right, cool beans. Okay, so that's pretty much how you do it. The answer is 6. Those of you who need me to show you how to do it, I'm showing you right now. Okay. 4 root 3 times root 3 is root 3 times root 3 is root 9 over 2. Can you see that? And root 9 is just 3. So it's 4 times 3 over 2, right? Because root 3 times root 3 is really just 3. That's all you need. You just need to write that. 4 times 3 is 12 divided by 2 is 6. So my coordinates are, what's my final answer? 2 root 3 comma 6. Now, if you want to write in complex number form, it'd be like this, 2 root 3 plus 6i. But our homework doesn't want to write in complex number, it wants to write it in rectangular form, which is parentheses, number, comma, number. So this is our answer. Remember, this was our x, 2 root 3. This was our y. Now, the thing is, it gets kind of finicky. Am I going too fast? Stop me if I'm going too fast, please. Wrote the answer down. So here's how we write our answer. You got to do it in parentheses, right? If you go 2 root, this is what I was doing yesterday, 3, make sure you hit that root there. And then you got to get this out of here, comma, 6. That's the right answer. But it marks it wrong because I did not put parentheses in. So I guess the proper form is make sure you do comma or parentheses, 2 root 3 comma 6, close parentheses. Okay, so there's our answer. Submit it. And then there you go. Okay, so polar form 4 root 3 comma pi over 3 is equal to 2 root 3 comma 6. And it shows here, right? I go over 2 root 3 and I go up 6, and that'll be the same as going over 4 root 3 and opening the angle of pi over 3. All right, let's do one more and then we'll move on. We'll be done. Okay, so am I sharing? Am I presenting? Okay, I'm going to have you guys answer this. I will get you started on it. But 6 comma pi over 6. Okay. Before I have you guys go on your own, let's identify our terms. Okay, what is the 6? See this 6 right here? What is my 6? Okay, let's go with Carlos. Tell me what it is. What's the 6?
The radius.
It's the radius. Very good. Okay, and then what is the pi over 6? Gianna, what's the pi over 6?
Theta.
It's theta. Okay, very good. So, final thing I need to show you before you guys do this on your own, okay, is remember, we need the x coordinate and the y coordinate, or the real number coordinate and the I number coordinate. But we'll say for x is equal to, what is x equal to? It's on your notes. I'm going to ask one of you, okay? What is x equal to? X is equal to what? The thing I said is very important for you to write. Eric Jones, what is x equal to? the formula? Eric Jones.
I didn't write it down. Can you go back to the problem?
What? Oh my! What? You're kidding me? No, Eric. That was super funny. Oh my gosh! Oh my gosh! Eric, I thought you said you didn't write it down. Okay, Eric, what is it? What is x equal to?
What's there?
Oh my gosh.
Which problem is it?
Eric, I love how you're pretending not to know. I'll ask someone else. You're so funny, man. You're so funny. Okay. All right, Eric. Gracie, what is x equal to?
R times cosine theta.
Pi times cosine theta.
R.
Oh, r. Okay. Yes, Gracie, very good. Okay. Gracie's right. X is equal to the radius times cosine theta. Okay. Hey, Eric. What's x equal to?
Radius times cosine theta.
Very good. Eric, what's y equal to?
Radius times sine theta.
Yes, very good. I knew you were messing with me. Radius times sine theta. Okay, guys, solve for x, solve for y. Go for it. You're on your own. Solve for x, solve for y. All right, let's see how we got this. Let's wrap this class up. Solve for x, solve for y. 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 Make sure you use your unit circle to find the cosine of pi over 6. Now, if you got the answer wrong, that's okay. I'm just going to ask you to tell me what you did, okay? And we'll find your mistake. Isaac, how you doing over there?
Yeah.
Do you have an answer, or do you need more time? Darth Isaac. I can't understand you, Isaac. You sound like Darth Vader. Are you a Sith Lord?
I don't believe I am.
Okay, that's very humble of you. Sith are usually not humble, so you're probably not a Sith Lord, so that's good. So, Isaac, did you need more time? I couldn't understand what you said.
Yeah, I need some time.
Okay, I think you said yes, you need more time. Jay, how about you? Jay.
Sorry, my
Wait, what? Jay, type it in. Type in your message to me. I can't understand you. You're breaking up. Sounds like your Wi-Fi is messed up. Let's see. Madison, do you need more time? Okay. Jay, I can't. You're breaking up, man. Let's see. Did you type it up? See, I keep on leaving and coming back. That was at 12:49. That was a long time ago you sent that. Carlos, how about you?
I need a little bit more time.
Do you get anything, Carlos?
Yeah.
All right, cool. Keep working on it. Ishi, how are you doing?
I think I got it. I don't know.
All right, cool. Hold on to that answer there. I'll wait till everyone else is done. Because I'm asking for 2 answers. John, how are you doing? You got the answer?
Yeah, I got it.
All right. Both of them?
Yeah.
All right, very good. Good work, John. I know you're right. Joshua, how about you? You have both answers?
Yeah, I got them.
All right. Are they right?
I hope so.
Oh, you better believe that they're right. Okay. Okay, I think we're about done here. Let's go for it. Let's see what we got. Does anyone want to volunteer an answer before I call on someone? Any? No one? Come on, tough guy. You got it. Okay. I'll pick someone at random. Isaac, give me something. What'd you get?
I'm almost done. I just need the last part.
Well, what do you got? You got the first part, you got X or Y or something? Tell me what you got, Isaac. Let's work with it.
I got Y.
What?
I got Y.
You got what? Wait. I can't understand. Man, you're
I
muffled.
got Y.
You got Y. Give me Y. What'd you get?
I got 3.
Yes, that's correct. 3 is correct. Very good, Isaac. Let's see. Donnell, do you get X by any chance?
I think
What'd you get? Tell me what you got.
3√3.
Yes. Everyone, very good. We got answer 3√3, comma 3. Okay, that's our answer. Raise your hand if you got that. Just I'm looking at you guys. Raise your hand. All right, cool. So that's all you got to do. I'll show you how to do it though. I'll show you what I got, and then we'll enter it, and then we'll be done. Okay. So we have here. It is the answer is 3√3, comma 3. All right, but x is equal to r cosine theta. So x is equal to the radius 6 cosine pi over 6, right? So I got my unit circle, cosine pi over 6. So I have here pi over 6, cosine is x, is √3/2. It's my cosine. Pi over 6 is √3/2. So it's 6 times √3/2. The 6 and the 2 become 3, but I can write as 6√3 divided by 2, or 6 divided by 2 is 3√3. That's that. Y equals r times sine theta. Y equals 6 times sine pi over 6. So sine pi over 6 is y. Pi over 6, my y is 1/2. So sine pi over 6 is 1/2. So 6 times 1/2, and half of 6 is 3. Now, so those are our answers. So let's enter it in Delta Math and be done with it. The main thing is, guys, for this whole lesson, like I said, x times r cosine theta, y times r sine theta. That's what you need, are those 2 things. Those are the main things. Let me know if I'm going too fast. So we have boom, 3 square root 3. Make sure you put the parentheses there. I'm telling you. Comma 3, close parentheses. Whoops. I don't know if that's going to mess me up. Let's get rid of one of those parentheses. I think that's good. And let's see what happens. Check mark. We are correct. You are correct, sir. And there's your answer. 3 root 3 comma 3. And that means polar form, rectangular form, we go over 3 square root 3, and we go up 3, and that'll be equal to radius of 6, angle pi over 6. And that's all you got to do for today's lesson. Wait till next year, man. This is what you're going to be doing next year. Not that bad. Are there any questions? All right, I'll see you guys tomorrow. Unless you want to have questions after class, you can go. You guys have a good one. Hey, finish the Delta math. Wait, before you go, remember, class actually ends at like 1:50. So do your homework till 1:50. Don't mess, just get it done, and then you'll be done with math, right? So right after this is over, finish the homework assignment. All right, I'll see you tomorrow. You guys can go. Who's saying bye? No one's saying. Okay. Bye, Joshua. Bye, Morella. Bye, Giovanna. Bye, Natalia. Bye, John. Bye, Ariana. Bye, Kayla. Bye, Ishi. Bye, Jasmine. Bye, Matthew.
I had a question about yesterday's assignment.
Yeah, let's do it.
I didn't really understand. Like, I got all of them except for when they
The hard ones.
When the angle's negative, I don't understand how to do those ones.
Yeah, okay. Those are the harder ones. Yeah.